So we've got power supply, we got resistance here, and we got electrical current. So we know the current is I, resistance is R, and the voltage V. So Ohm's law, V equals IR. Okay, so units. Okay, so we know that the resistance is measured in ohms, and the symbol for an ohm is a capital Greek omega. Okay, so V equals IR. Okay, so we can also say V over I equals R. Well, in engineering, we often have another sort of thing that we talk about, that is conductance. And so conductance would be if you had I over V, so the current per voltage, and that's G. So in other words, I equals GV. Okay, we use G for conductance because we're using C for other things. So what would be the unit of that? Well, obviously, the unit is 1 over ohms. Okay, and officially, that is a Siemens. So that is the unit right here is a capital S. Okay, now, the problem is that capital S, well, that's the official unit, but the problem is the capital S is sometimes difficult to see in an equation because we use capital S and lowercase s for other things. So that makes it sometimes confusing. Secondly, it can be mistaken for a 5 if you're not looking very carefully. And so a lot of engineers still use a ohm to the minus 1, or if they write it out, we have an ohm is the unit of resistance, so that's going to be ohm. So this is sometimes called a mho, okay, which is ohm written backwards. All right, so I know it sounds silly, but that's sometimes actually done. Okay, that's not official anymore, but some old books have that, and some older engineers still talk about mhos. Resistivity. We know that R is rho L over A. Okay, so the resistivity has units of ohm meters. There's also conductivity. Okay, so conductivity, so this is resistivity. Conductivity, and that is 1 over rho. So that has units of 1 over ohm meter, or technically it is a Siemens per meter, or sometimes that's written as a mho per meter. Okay. And so these are our units right here. Okay. And so you think about it, and so now we have units, and again, this is all kind of a confusing mess. Okay, because if you think about it, resistance is V over I. So a volt here. So a volt is a joule per coulomb, and amp is a coulomb per second. So resistance, this is going to be ohms, and ohm is going to be a joule per coulomb per second. Okay, in other words, this is a joule second per coulomb squared. So this is a kilogram, joule is a kilogram, meter squared per second squared times second over coulomb squared. So an ohm is a kilogram meter squared per second coulomb squared. Okay, and so once again, I hate units with this physics 2 stuff because we end up with these confusing messes of units all over the place. And when I was a student, I had to keep a little sheet of paper to keep track of all the units.